Hello everyone. In today's lesson we will talk about solving a linear system of equations. There are various ways to solving them, and today we'll get started with the more visual method, the graphing. A linear system of equations is nothing but two linear equations connected to each other by this bracket that we call braces. As you see here, we have y equals x plus 4, a linear equation. See that the exponent to both x and y variables are 1, or you don't see anything, which assumes is 1. And in order to solve them, we must write both equations in slope and y-intercept form. Recall from grade 9 that slope y-intercept form of an equation is y equals mx plus b, which means that y must sit in one side of the equation all by itself, no coefficients in front of it, and the other side of the equation will have the rest of the terms listed in order, x term first and the constant after. Now before the x term, you see the letter m in here, and you remember that this is what we call the slope, which indicates the steepness of the line, and this indicates the y-intercept, which tells us where the line intersects the y-axis. Now remember that slope is easy and fun. Just remember to rise and then run. Okay, so y equals x plus 4, which is our first equation, is already in slope y-intercept form because we have y by itself in one side of the equation, coefficient is 1, and the rest of the terms are in the other side of the equation with x coming first and the constant term after. The second equation though, y equals 2 minus x, is almost in slope y-intercept form, but we need to make some adjustments. So remember that we want y by itself in one side of the equation, which we do have, but then we want to start with a constant, with the x term, not the constant. Now the x term in here has a minus in front of it. This minus will go wherever the x goes. So we'll rewrite this as negative x, and the constant number is a positive 2, so plus 2. Remember, we're not switching the sides. They're still on the right side of the equation. Now, once we know we do this, we need to graph them. So we have to graph each line on the Cartesian plane. Now, in order to graph the line, we need to identify the slope and the y-intercept first. So I'll write this down for us here so we remember. So the slope for the first equation, since we don't see anything before x, I'm going to say is 1. The y-intercept is 4. Now remember that we always want to write the slope in fraction form so we can see more easily what the rise and the run are. So I'm going to play smart here, and I'm going to write m as 1 divided by 1, which is totally fine because we can write any number as a fraction with denominator 1. Now, the same thing with the slope of the other equation. So we're going to say in this case we have negative sign, which indicates that the slope is negative 1. We want it in fraction form? No problem, negative 1 over 1. And the y-intercept would be 2. So let's get graphing. I'm going to start with the first equation. Y equals x plus 4. I said we'll start from the y-intercept. And the y-intercept indicates where the line intersects the y-axis, so we are at 4. And from the y-intercept, we apply the slope. Now, I want to show you a little trick here. You see how the slope is 1 over 1, because the slope was equal to 1. We may write the slope in two different ways. We can write it as 1 divided by 1, which equals 1, or as -1 divided by -1, which is again +1. So from y-intercept of 4, I can rise 1 and run 1, which means go up 1 and go to the right 1. So let's do that. So you have to go up 1, run 1. There goes the first point. Again, if you want to move to the next point, you go up 1, run 1. You stop here again. And you can continue on forever if you want, or until you run out of space, obviously. Now, if you want to apply the slope as -1 over -1, that is still perfectly fine. Do you think you are going to get outside the line? Do you think the pattern will be disturbed? Let's check and see. So if you rise -1, it means that we are going down 1. And if you run -1, it means you're going to the left 1. So if you go down 1 and to the left 1, you land on this point right here. And you can continue on, actually. So go down, go to the left, go down 1, go to the left, go down 1 to the left. And you create this bunch of points. As you see here, they make a straight line. What I'm going to do is try to connect them all together. I'm going to try my best because sometimes it's not easy. The pen doesn't do whatever you ask it to do. Okay, not too bad, not perfect, but it's okay. So this will be y equals x plus 4. In the same way, we're going to do y equals -x plus 2. This will be a bit faster because we don't need to explain as many things as we just did with the other line. Okay, here we are again. We start from the y-intercept, remember? And we can apply the slope again as -1 over 1, which means that we rise -1, so down 1, right 1. So from the y-intercept, we can go down 1, right 1, down 1, right 1, down 1, right 1. That will create these points. Now, similar to this, we can consider the slope as the fraction of +1 divided by -1. So that means that we may as well write or draw the line by rising 1 and running -1. So 1 up, 1 to the left. So from the y-intercept again, always from the y-intercept, you rise 1, left 1. Up 1, left 1, up 1, left 1. So you will create a bunch of points in here. And I'm going to try to connect them all. As you see here, we have a pattern. So all the points will form a line. Okay, not perfect, but here is me trying to make it work here. And here we got both lines connected. Now I want to talk to you about something really important. How do we find the solution? Now, let's take a look at the pink line, y equals x plus 4. Any point that is on this pink line can be identified by its coordinates. So for example, this point here is 0, 4. This one here, 1, 5, 2, 6, 3, 7, 4, 8. Okay? So what I'm going to do is write the coordinates 0, 4. Or the next point, we said 1, 5. These are all points on the pink line, 2, 6. If you substitute these points into the equation, remember each point represents an x and a y, right? Then we will have, for y equals x plus 4, we will have x equals 0, y 4. So 4 equals 0 plus 4. Is this true? Yes. If x equals 1, y equals 5. So you can say that 5 equals 1 plus 4. Is this true? I'm going to say yes again. Y equals x plus 4 or 6 equals 2 plus 4. Is this true again? And we're going to say yes again. So as you see, all these points will satisfy this equation. And where are all these points located? On the line. How many such points can you find on this line that can satisfy this equation? We'd say, well, any point on this line must satisfy the equation. Okay? So in this case, we'll say that there is an infinity number of solutions to the equation of the pink line. Okay? Same thing can be said for the green line. So there is an infinite number of solutions that lie on this line in here for the equation of y equals 2 minus x. But there is one solution that both lines will have, which is indicated by the point of intersection right here. The point of intersection of the two lines will represent the solution to both lines, or in other words, the solution to the system. And that's why the next step to solving the system of equations is identify the coordinates of the point of intersection. The reason why we want to identify the coordinates of the point of intersection is because that is the solution to the system. Okay? In our case, this point has the coordinates x equals -1 and y equals +3. So we're going to say that x equals -1 and y equals +3. Sorry, that wasn't supposed to happen. Is a solution to both equations or the solution to the system. If we want to test this solution, we can substitute it into both equations and check and see if both sides of the equation will become true. So x is -1, y is +3, so 3 equals -1 plus 4. 3 equals 3, so it works. And for the next equation, y equals 2 minus x, we have 3 equals 2 minus -1, or 3 equals 3, so it works for both of them. And this is what we call checking the solution to the system of equations. And this is the last step, stating the solution. And there goes our solution right here. Sorry. Okay. So this is how we solve a system of equations by using the graphing method. Now, how many solutions can a system of equations have? That will depend on the graph of the line, or the graphs of the line. If the two lines will intersect at one point, the equation of the system will have one solution. But sometimes it can happen that both lines will fall on the same y-intercept and steepness, will have the same steepness. In this case, we will say that there is an infinite number of solutions because they have same slope, same y-intercept, so it's basically the same line. And sometimes the two lines may have the same steepness or the same slope, which makes them parallel to each other, but their y-intercepts will be different, which splits them apart, right? In this case, they will never meet each other. They will never have a common point. And in this case, we're going to say that there will be no solutions to the system of equations. Now, this is the first part of the lesson, and I have a few more examples that I want to try with you. I'm going to write the solutions, but I want you to actually stop the video